Okay, what we are learning about today is two new distributions that hopefully you read about already. They're called a binomial and a geometric distribution. This section is a lot of numbers and calculator work. It's not too much written work or interpretation. Here's what I need you to know. Binomial and geometric are special discrete distributions. So discrete, we've already talked about, something that we're measuring. It's a variable on a number line that can only take on specific values, not the entire interval on a number line. Before we even get to the example, I want to tell you what a binomial distribution is and its main properties, and then we'll do some calculations. Here's what I need you to know. A binomial distribution. You are looking at a certain number of successes and a fixed number of trials. So in the example above, it says 12% of manufactured mufflers are defective and 10 are selected at random. 10 is the fixed number of trials. We're always looking at 10 mufflers. There are 4 different properties or requirements for a distribution to be binomial. The acronym that you can remember is BINS. Here's what that stands for. B means that your situation has to be binary. So there's only 2 options, success versus failure. I stands for independent. So your trials have to be independent. Whether or not the first muffler is a success or failure needs to be independent of the second one. This independent is not going to be stated. So this is not like probability independence where we're going to check for it or it will be stated. You're just going to use your own contextual knowledge. N stands for fixed number of trials. So like we talked about, 10 mufflers, that's a fixed number of trials. And then S, the probability of success. Is constant. So the probability that the first item is successful has to be the same as every item after that. It can't change, and that just comes with the independence part. Again, that's not going to be stated. None of these are going to be stated. You're just going to have to do a mental check. Okay, so here's our example. If 12% of manufactured mufflers are defective and 10 mufflers are selected at random, find x equals 0 by hand. Okay, here's how you're going to start. First thing you need to do is you need to tell me what x is. Okay, so in this case, we are looking for defective mufflers out of the 10. So x is going to be the number of mufflers out of 10 that are defective. Okay, so here's why this is binomial. We have a fixed number of trials, 10 trials. We have a success or failure. Our success in this case is the muffler is defective. So the failure then, it's not defective. Our trials are independent, so we're assuming that the status of the first muffler doesn't affect the ones so on and so forth. 12 trials, and the probability that the first muffler is defective is 0.12, so on and so forth for the remaining mufflers. Because this is binomial, you need to say that. There's very specific notation. We're going to say x is distributed as binomial, and there are 2 important numbers. The first one is the number of trials, which is 10, and it needs to be labeled n equals 10. Second one is the probability of success, which is 0.12. That's the probability of a defective muffler. One note for you, your book does not use P, your book uses pi. So if you've read that, we don't use pi, we're going to use P because that's what the AP test uses. Okay, so jumping in. For A, the probability that x equals 0. That means that there are 0 defective mufflers out of the 10. So out of 10 mufflers, none of them are defective. Well, if the probability of being defective is 0.12, the probability of not being defective then is 0.88, and there are 10 of those mufflers. So that's about 0.28. Okay, so what that means is, if we looked at 10 mufflers a whole bunch of times, like over and over and over again, 28% of the time, out of those 10, none of the mufflers are defective. So that probability says nothing about one set of 10. It's talking about in the long run if we looked at a whole bunch of sets of 10. Okay, for B, find the rest of the distribution. So we need to find the probability that x equals 1 all the way up to 10 defective mufflers. I'm going to show you in a minute how to do this on the calculator, but I want to explain. If we were finding the probability that x equals 1 by hand, that means there's one defective muffler. So we have one defective muffler, that's 0.12. We have 9 that are not defective. But what do we have to do now? Multiply by 10. Kelsey, why 10?
Is there 10 ways in which one can be defective per se?
Right. If we looked at 10 mufflers, one could be defective. It could be the first one, the second one, third one, all the way up to the 10th. So then if we did that, we get about 0.47. Do we see that as soon as we get to the probability that x equals 2, it's going to get a lot harder? Like, how many ways can that happen? I don't know off the top of my head without writing them down. You guys agree? Okay. The calculator will do this for us. So we're going to calculate this probability that x equals 1 again on the calculator, and then we'll do 2 and 3. We're not going to do all the way up to 10. Okay, here's what you're going to do. On your calculator, there is a distribution button. I think we've used it once before. You can look over here. It's above vars. So that's what this DISTR stands for, is distribution. If you hit second distribution, the first one you should see is normal PDF, and then you see normal CDF. Okay, scroll down for a while, and eventually you're going to see binomial.
Binom CDF.
You should see binom PDF and binom CDF. Do we see both?
Yeah.
Okay. What we are going to be using is binom PDF. And I'll talk about CDF in a minute. Binom PDF calculates a binomial probability at a specific x value. So if you click that, it then should ask you for some information. It says trials, which is 10, P, which is 0.12, and the x value in this case is 1. And when you hit paste, oh, we don't get 0.47. That's not good. Oh, that's because this right here should be a 0.37. Sorry, I put a number in my calculator wrong. 0.38. Yes, 0.38. I put a number in my calculator wrong.
0.12.
What?
He asked me a question.
Okay. Does everybody have a calculator that when they choose binom PDF, it tells them trials P x value? Okay, and so you put in 10 trials, probability of success is 0.12, and x is 1. Okay, so do that again, and I want you, just for fun, to find the probability that x equals 3 using binomial PDF on the calculator. And you should get about 0.085. Do you? 0.85? Well, probability can't be negative, so.
Well, it says negative 0.085, so I don't know how I got.
Priyanka or Kanya, can you look at his calculator and see how Luke put that in? Okay. And then you would keep going. We're not going to find the rest of them, but that's how you would. Good so far?
All at the same time.
Huh?
Is there a way to find them all at the same time?
The way I would think you could is if you used a list and entered in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then did the binomial of that list.
What's that?
That might work. That being said, I'm never going to ask you to find all of them. I'm going to ask you only one value.
What's the work we need to do?
Okay, I love that question. There is a complicated formula that you don't have to show as long as, this is the most important thing, if you show this line right here and a probability notation, you don't need to show the formula. But this red box is considered showing your work. If you do not explicitly write this out, you will not get credit. And I'm going to show you the complicated formula in a few minutes. Well, just for fun, let's look at it now.
Should we use that sign too that like half the
You don't have to, but that's just the general notation, or the commonly used one. Okay, ready? Here's the formula. The probability that x equals k is n choose k, p to the k, 1 minus p to the n minus k. You've seen this before. Do you want to use it? No. Nobody wants to use that. So don't use it if you can just write the thing that's in the box. And a probability notation. Do you guys remember talking about this before?
Yeah.
So for the probability that x equals 3, what would n be? 10. K. 3. 0.12 to the third. 0.88 to the seventh. Okay, can we keep talking? Yeah? Okay. Let's go down here. Okay, part C. Find the probability that 2 or fewer are defective. So the probability that x is less than or equal to 2. Now, of course, what we could do is we could find the probability of 0 and find the probability of 1 and find the probability of 2 and add them together. But we're lazy, so let's be efficient. When you go to second distribution again, I told you we're going to use binomial PDF. You should be wondering what binomial CDF means. So that binomial CDF, C stands for cumulative. Specifically less than or equal to. So if you go into CDF and put your 10 trials, and P is 0.12, and your X value is 2, this is what it calculates. When you put in 2, it actually calculates less than or equal to 2. And so when I did that, I get about 0.89. You guys agree? Can anybody confirm you got 0.89? Thank you.
For this, should you still write the binomial n equals 10, p equals 0.12?
As long as you write that somewhere in the problem, it will carry through. So you don't need to write it again for every step. We are going to do D and E, and then we'll take a break. Okay, so D, find the probability that more than 2 are defective. You cannot do that more than 2 in the calculator the way that that is written. So what I would do is think about, well, what does that mean? What that means is 3, 4, etc., all the way up to 10. The calculator does not do greater than or equal to. It only does less than or equal to. So if we're going to do CDF on the calculator, what we're going to do is find the probability that we're not interested in, the complement. So if we're doing 3 and greater, the complement, the cases we're not interested in, would be less than or equal to 2. So, I mean, conveniently, we already did that. So we would take 1, subtract that less than or equal to 2, because less than or equal to 2 is the complement. So that probability of x greater than 2 then is about 0.11. Okay, if I asked you, find the probability in this same case that x is less than 6. You would use the CDF on the calculator. What number would you put in for x? 5. So what I'm saying is that's the same as x is less than or equal to 5. So you would have to use 5. If I asked you for the probability that x is greater than 4, how would you do that on the calculator, since the calculator doesn't do greater than? So greater than 4 would be 5, 6, less than or equal to 4. And that work you do need to show what you're putting in the calculator. Does that make sense? Okay, and then does E ask for the mean and standard deviation? Yeah. Okay, so E, the mean of a binomial distribution is n times p. So our 10 times 0.12, so the mean is 1.2 mufflers. And again, you should know how to interpret that. If we looked at a bunch of sets of 10 mufflers, the average number that are defective would be 1.2. Standard deviation is the square root of n times p times 1 minus p. So we're going to have the square root of 10, 0.12, 1 subtract 0.12, which is about 1.03. And again, that's the typical deviation from the mean if we were looking at a whole bunch of mufflers over time.
Will we get these formulas on the formula sheet?
Yes, these formulas are on the formula sheet. So once we're done taking all the notes, we'll look at the formula sheet and I'll point these two out. That is a binomial distribution. Questions for me in terms of formulas, the work that you need to show, anything like that? So that is binomial distributions. We're going to talk about geometric. Geometric should go pretty quick because it is related to binomial. Geometric is the other type of discrete distribution that's very well known. Here's what you need to know, so write this down. Geometric distribution. You are looking for the first success. The first success. Out of the acronym BINS, The n does not apply. There's no longer a fixed number of trials. Everything else still applies, though. It's still binary, either success or failure. Your trials still need to be independent, and your probability of success still needs to stay constant. Okay, so in the board game Monopoly, one way to get out of jail is to roll doubles. Y is the number of attempts it takes to roll doubles one time. So that one time tells us we are looking for our first success. Now, we don't need to define y because it was already defined for us. But we do need to say that y is geometric. There's no n, there's no fixed number of trials, but there is a probability of success. Our success in this case is rolling doubles. What is the probability of rolling doubles?
136.
1 out of 36.
I was waiting for that.
Okay, so part A. Find the first two values in the distribution. Probability of x equals 0 doesn't make sense. That would mean you don't roll at all. So we don't start there. We start at 1, which just means you were lucky and you rolled your doubles the first time you rolled your 2 die. X equals 2 then means you didn't roll doubles, and then you did. And that's some number. If we did x equals 3, you didn't roll doubles twice, then you did. Again, that's some number. We don't have to multiply by any constant because there's only one order. No doubles, no doubles, doubles. Okay, if we now found the probability that x equals 4 and x equals 5 on the calculator, you can probably figure out how to do this if you go back to second distribution.
So the probability of rolling doubles 1 out of 1/6 is 6 roll 6 different doubles.
That's what I was thinking.
That's what I was.
But I think maybe they're only talking about sixes.
No, it's just doubles.
What's double?
So like a 1 and a
Same
1,
number
a 2,
or-
yeah.
So yeah, then isn't it 1/6?
No, it's not that frequent. Because if you were to think of writing out all the possibilities of what you could roll, on the first die you could roll a 1, 2, 3, 4, 5, or a 6. You have 6 options on the first one. You also have 6 options on the second one.
Oh wait, are you saying that there's 6 different doubles you could roll out of it?
Oh, okay, I'm with you. I'm with you.
Oh shoot, I just shot my own idea down.
Oh. Okay, yes, I agree with you all.
Yeah, I was wondering.
Yeah, I was wondering that too, yeah.
I was so confident.
Yeah, me too.
Yes, I was also searching it up. I searched it.
Why did you all let me get this far and then not tell me?
Guys, this is why I don't
I
answer
didn't know
questions.
what doubles were because I don't play Monopoly.
Well,
I'm actually at Monopoly.
okay.
Just stop right there.
Okay, so let's try that again. Okay, probability of rolling doubles is 1/6. So this would be 5/6 and 1/6, 5/6 squared and 1/6. Okay, better. Again, if you go to second distribution and you keep going down, if you go down past the binomial, you'll next get to Poisson, and then you'll get to geometric. So on your calculator, you should have geometric PDF and geometric CDF. You guys with me?
See.
Okay. Do you think we're going to use PDF or CDF? PDF, we're just looking for a single value. You'll notice n is not there. So we're going to put in p, which is 1/6. Our x value is 4. And you should end up with a probability of about 0.096. Do you? Okay, do it again one more time and calculate the probability that x equals 5 just for fun. And you should get about 0.08. Okay, questions? Okay, C, mean of the distribution. The mean is 1 over p. So our mean is 6. So in the long run, if you played Monopoly a whole bunch of times and you were in jail, on average, you should need to roll 6 times to get doubles. Okay, what I would like you all to do right now is take a few minutes to do D and E with the person next to you. Hopefully you can tell you're going to be using geometric CDF. So I want a probability notation and an answer. Good luck. Okay, less than 2 is just the probability that x equals 1. That's the only possibility less than 2. So 1/6, or if you did less than or equal to 1 on your calculator, you would have got 0.167 or something like that. Less or equal to 2, that comes right off the calculator. Here's the one in E where I want very specific notation. Greater than or equal to 4 is not what you did on the calculator. I don't need to see all of this. What I do need to see, though, is that you did less than or equal to 3 and you subtracted it from 1. So less than or equal to is what the calculator will do. Okay, so that should be very similar to the binomial. Again, you do not need to show all of this work except this box. There's a formula for geometric. We don't want to use the formula. We're lazy. Let's be efficient. Tell what type of distribution it is and then give probability notation and you're good to go. Questions for me before we do the last set of examples? Okay, like transformations and combinations, what is difficult about binomial and geometric is being able to recognize them. So that's what we're going to do. We are going to do one of these together, and then you all are going to do the rest of your group. The first one, when an opinion poll calls residential telephone numbers at random, only 20% of the calls reach a live person. You watch the random digit dialing machine make 15 calls. X is the number of calls that reach a live person. First question we need to ask ourselves, is this indicative of binomial or geometric? Binomial, there's a fixed number of trials, which is 15. So then we need to check the 4 properties. Binary, is this binary?
Yeah.
Yes, you reach a live person or you don't. Independent, are the calls independent?
Yeah. Good.
I'm going to say probably. Fixed number of trials, we already talked about. Does the probability of success stay the same?
Yes.
Yes. So I would call this binomial. Now, does anybody have an argument? Because there is one as to why this could not be binomial. We don't really know the independence. It's possible that some people have more than one phone number. And so if you were to call that person and whether or not they pick up, if their number gets chosen again, not really independent. But I would argue that that really isn't something we need to be concerned about. What I want you to do is the next 3. Is it binomial or geometric or neither? Okay, the second one with Lawrence shooting the bow and arrow. Indicative of binomial or geometric?
Geometric.
Geometric. Is it actually geometric or is there something that is not met?
I think it's actually geometric.
Anyone argue otherwise? Leah, what was your argument?
If he keeps practicing, he's gonna get better and better, so his
Hey.
probability-
Can you guys hear anything that she's saying at all? Can you start again, please?
When you're learning how to do something, like, especially like shooting a bow and arrow, the probability that you're gonna hit a bullseye is gonna go up and up as you keep practicing, so the probability isn't constant necessarily.
Yeah, I would argue that these are not independent, that your probability of success does not stay the same. This is neither.
Trick question.
Because he's not not shooting a bow and arrow with his eyes closed. He's gonna shoot, see where he messed up and adjust. So in all likelihood, he's gonna get a little bit better, hopefully. McDonald's one? Neither. Why?
Because you said that there was no like constant probability related to it of whether you're gonna get both things.
Okay, so there's no constant probability. Did anyone think differently or have a different reasoning?
Does geometric have to be, it stops at one success or it stops
Yes.
at two successes?
Yes. That is why I would say this is not geometric, is we're looking for two successes here. Two pieces of property, not just one. This is actually called hypergeometric. We're not going to do that, but just so you know, that's not geometric, so that's also neither. Last one, shuffling the deck of cards and flipping them over. Yep. Probability of success does not stay the same. Okay, formula sheet. I don't know how much of these we've talked about. What I will tell you is out of the ones at the top, you don't need this formula. And then if we look at this box, did we talk about these formulas being on here? Maybe we did, maybe we didn't. But here are the ones that are important. So those are your binomial and geometric formulas. So you have mean, standard deviation, mean, standard deviation. Now, here are the two that are optional. You really never need to show this or this as long as you define the distribution. So for example, if you say something is binomial with a given n and a given p, that takes the place of the formula. That means you don't have to use the formula. That being said, you need to understand how to read this because it has shown up in multiple choice questions before. So what I've seen in multiple choice is a written description, and it'll say, how do you calculate this probability? And then it'll give you work with no answers, and you need to be able to pick out, this is binomial, use the binomial formula. So I will not force you to use it, but you do need to be able to recognize it. Ian?
On AP FRQ, is it true we don't need to write that formula out either?
Correct. Yeah, the only time you would be forced to use it is multiple choice. Okay, we don't have time to do more show your work, so we're going to do a few multiple choice, and then we will call it a day.